Okay, so the exam one was graded, and everyone should have received an email. Don't go to your email. All of this is just your attached graded exam one. The answer keys, the answer key for exam one is posted. I would go ahead and take a look at it. Even though the final exam, oh, there is no final exam. So even though we don't have a final exam, um, the types of mistakes that you are making on your exam one, maybe it could be a mechanism error, it could be missing charges, it could be not understanding uh, how to write a mechanism or how to do synthesis. It would be worth looking at your exam one and compare it with your answer key, uh, and that should help uh, minimize general mistakes. Okay? The next thing, and we'll go to Moodle in just a bit. The next thing is in terms of the material that's available. Unit 4, hopefully you were able to hand in your notes, submit your notes for the Unit 4 videos. There were only 3 of them, and they were on what's called organometallics. So there are 3 total. Uh, Today we're going to look at some of the problems from Unit 4, and I do want to give you more of an introduction to Unit 5, which is going to be carboxylic acids. And lipids. All right. The plan was to talk a little bit about this biomolecule. This would be biomolecule part 2. Part 1 was the carbohydrates. Lipids such as phospholipids, those make up your cell membrane, surfactants, which are detergents. All of those types of molecules, um, especially the surfactants, are carboxylic acids, but I think I'm going to leave that up to if you're taking genetics or if you're taking uh, microbiology. They'll talk about lipids because you'll be working with cell membranes, trying to get at the DNA of certain cells. I'm not sure what cells you guys are working on in biology, but I'm going to save that for someone else, one of the biologists. What that means is that carboxylic acid, probably there's going to be uh, 3, maybe 4 total, but we'll go with 3. I'm going to try to get all of those in today. Um, Looking ahead, I did warn you on an email that Unit 6 was going to be pretty large, um, but the thing is, it is built off of the Unit 5. So Unit 6 is called carboxylic acid derivatives. Just, oh yeah. So the plan is, because this unit is fairly large, I do want to sort of put the lab aside. I apologize for that. We're not going to get through as many quote unquote experiments as I wanted to, but uh, for this carboxylic acid derivatives, the idea is to get as much material as soon as possible. And if I get maybe 3 videos, oh, that's a lot. But if I get 3 videos up by, let's say, give me 1 second when I figure this out. Let's say 10 p.m. Today, Wednesday. You see that? So if I get 3 videos up for Unit 6 up by tonight, Wednesday, then the notes check will be on Unit 6 and whatever I get up on Unit 6. I'll try to make this a little more clear once I get a better feeling of what I can put up, but I think I could put up 3 videos. The notes check, uh, as usual, will be at least a day. So we'll make this is the day. So the notes check will be Friday, 8 a.m. Okay, so that's the deal. If I could get maybe 3 videos up for Unit 6 by tonight, we'll have all of tomorrow, Thursday, to get those 3 video notes in by Friday 8 a.m. The idea is to have everyone on the same page by each Zoom class. Like for instance, today, hopefully everyone turned in their organometallics notes. Then I feel very comfortable reviewing or going over some problems on organometallics for today. So that's the plan. Um, go make sure you. This is Jose in? Oh boy. Hopefully you could hear me. I think one of my posted notes was covering up the microphone. Um, Let me just double check something. Yeah, hopefully you heard me. But everything important is listed here. Why don't we look at Moodle, and then we're going to look at some problems from organometallics or do a little bit of review. Okay, on Moodle, what do I have on Moodle? Okay. We're here on Wednesday. Again, hopefully you submitted your notes. Oh yeah. Um, while you wait for me to get as many videos as up as possible by 10 p.m. today, you could benefit your grade. You could definitely work on getting points for your exam too by doing some of this extra credit. Now, the extra credit I'm going to talk about during today's lecture. So there's nothing posted. There are no instructions. There are no problems posted yet, and I'm not going to post any problems. It's all going to be from the notes, and we'll just knock out enough problems for you to do between now and 10 p.m. Uh, to earn that 4 percentage points. Okay, and most of you probably realize that those extra credit points, it could be between, on average, 8, but I think the maximum this exam 1, was 14. Um, Obviously, that could push your grade up at least 1.5 letter grades higher. So we'll try to get you some extra credit today. All right, the organometallics. It's a great, I try to emphasize this, it's a great way to make a carbon-carbon bond. And the only thing is, when you make a carbon-carbon bond with an organometallic, mostly or mainly, you'll get an alcohol. Why don't we do a roadmap? Okay, whoops. Am I connecting? Just give me 1 second. I imagine no one's hearing me right now. Something's going on with the Wi-Fi. Give me 1 second. Get on the phone. Oh, sorry about that. Um, Sorry about that. I, I I believe we lost connection. Let me try to get us back to where we were looking at. Give me 1 second. Oh my goodness, this is horrific. Mm, back, or at least I'm back. Oh, man. Okay. Temporarily lost connection. Um, we'll get to the extra credit that you could do today for plus 4 percentage points, but let me go over, or let's do together a, what do you call it, a roadmap. And the roadmap is going to be basically two cities, uh, the Grignard reagents and actually the Gilman reagents. Those would be two different cities because they actually do two different things. So let's take a very actually common Grignard reagent. If I need to write bigger or more legibly, let me know. This is phenyl magnesium bromide. It's something that we could buy from a chemical company. It's great that we could buy a Grignard reagent from a chemical company. It's actually pretty hard to make one because, as you know, if any moisture is present, then it's very hard to make this because it will automatically react with water to put a hydrogen on that carbon, and all you'll get is a benzene ring. Okay. Um, what they do when they sell this is they sell it in a sealed bottle that's protected from the air because all air has some humidity in it. So it's sealed in a bottle, and to remove the reagent, you got to use a syringe and try to keep that environment inside the bottle air free. Um, so the first thing is maybe not even start at the city. How do we get into the city? How do we get into the city? So that's a synthesis. Actually, I'm going to leave this, no, fill in some of this at least. What am I going to do? The cities are going to be in blue. Let's say the reagents are going to be in green. And I'm going a little bit fast. So if you see that I'm making a mistake, just speak up. Um, I don't know if I could see people raising their hands or chatting. I would just speak up. Okay, Grignard reagent. So what are the first reactions of using the Grignard reagent? By the way, you could also use an organolithium. It's the same, exactly the same types of reactions. Let's go up here. Let's take an epoxide, and not only an epoxide, but an asymmetrical epoxide. Okay, so now it matters which dot you attack, and do you know which dot you attack? That's one, and then normally there's a protonation. Because when you mix the epoxide with the Grignard reagent, there's no acid. There can't be any acid. Because if there was acid, this will act like a base and grab that proton. So under the presence of no acid, you know that you attack the less substituted carbon. And when you attack the less substituted carbon, you kick up this bond here. You break this bond. So you have to visualize where is your OH going to be. You attack the dot. You attack the dot. And if you attack the dot on the right, the OH ends up being on the dot on the left. So that turned around, but it's on the other carbon that did not get attacked. And then we have that methyl group. Another thing that we could do is that if you want to sort of prep yourself for synthesis, then ask yourself, well, what bond was made when I use an epoxide? It's not this one, right? This would be very tempting to pick because it's connecting the functional group with the original molecule. So a lot of people will be fooled into thinking that this bond was made. But that can't be right because this is only benzene. There's no seventh carbon. It was this bond that was made. That bond was made. So when you go through a retrosynthesis, or when you start working backwards, and I'm forcing you, if I force you to use an epoxide, you have to find the bond that's actually one carbon away from the OH group. This one's tricky because this is very distracting. The OH is kind of tempting you to say that this is the bond that was made, not this one. So that's an aside. Just I just feel like that's a mistake that a lot of people make on an exam. And then, according to our the YouTube videos, that star, there were 4 other reactions that we can do. We could do formaldehyde. And because we're doing a Grignard reaction, most likely you're going to have a O minus that has to be protonated. So in all of these cases, you will need H2O plus. I think on the practice problems, I also say HCl, hydrochloric acid, with water. What's another trick? See, the trick is I put dots on the carbon that potentially could be attacked. So there's the dot right there. Okay. Let me fill in the rest of the reactions, but I'm not going to fill in the products this time. You could do that on your own. We could take a regular aldehyde. Regular meaning that it only has 1 hydrogen, not 2 like formaldehyde. We could take a ketone, and I'll make it symmetrical. And again, HCl plus. What was the last one? The last one was, I do want to talk about this a little bit, carbon dioxide. Dry ice. The beauty of using dry ice to make the carboxylic acid is that you could put as much dry ice as you want to try to drive the Chatelier to the product, and then any excess carbon dioxide just disappears. It evaporates into the air. I'll draw the product for this. If I recall correctly, I think we started with this A, B, C, D, E, F. That sounds right. There's a reaction that I did not give a letter to. It's a reaction that destroys the Grignard. And a lot of times when this happens, it's by mistake. It's not, there's very, I can think of one reason why you would want to do this reaction where you have H2O. Any moisture in the air, that bond will attack a proton to put a hydrogen and make benzene ring. So some people like doing this. They draw the benzene ring. I don't particularly like doing this, but to emphasize that there was an acid-base reaction, see that's green? The green H came from the green water. So what's left over? The green OH minus and the plus MgBr. So this is not a lettered reaction in my notes, but this can happen if you're not careful. Okay, and that's why when you make the Grignard reagent, you have to use what's called an anhydrous solvent. Mechanisms, okay, in pink. Since all of these rely on the bond to attack an electrophilic carbon, you are responsible for all of these mechanisms because they're all analogous. Look at all of these dots. Grignard attacks that dot. Grignard attacks that dot. Grignard attacks that dot. Grignard attacks this dot. Carbon dioxide literally looks like a diketone. It's a carbon with 2 double bond oxygens, right? CO2. So that's the dot you're attacking. You're attacking this dot, the carbon. And that's why we have this 7th carbon right here. This was the green dot right there. Okay. All right. Now, there was some extra credit on exam 1. Let me just double check my participant list. There's some extra credit on exam 1 that, how do I get out of here? Oh my goodness. Um, there's extra credit on exam 1 that asks you to um, send me any study aids that you went above and beyond just the regular notes. I mean, that's what's going to take. That's what that's what it takes, to go from maybe, not passing to passing. That you, on your own time, reorganize your notes, make roadmaps, do note cards, flashcards. So I do want to talk a little bit about. There were some really impressive um, study aids that I saw uh, posted or submitted, and many of you did flashcards. Some of you did. I know we did the roadmap for one of the units, but for the other units, you again went above and beyond and drew roadmaps for those based on this formatting. Let me give one suggestion about note cards, flashcards. What you want your flashcard to look like actually on the front is an exam problem. Okay, you want to get used to, and all of you, except maybe one or two, know, the type of problems that you want to get used to seeing those. So let me think about a reaction. Let's talk about the carboxylic acid reaction. How to make a carboxylic acid reaction. Instead of recopying all the notes on the front of the note card, why don't you do something like this problem? Okay, and let me give us organolithium, CO2, and H3O plus. So I have the biggish note cards. I think they're 4x6, and I write pretty small, so I could cram a lot of stuff in here. But what would a problem be here? So I know that those people who are doing flashcards, I probably can find in your stack a note card or two or three based on this Grignard plus carbon dioxide or organometallic plus carbon dioxide. But the way that I would do this is I would make it a question. So here I would say draw the product. Okay. You know me, if there's some stereochemistry that's appropriate, I may say with the appropriate stereochemistry. But the thing is, with a Grignard plus carbon dioxide, you're not making a chiral carbon, right? This carbon here is not chiral, and that's the carbon we added. So there really isn't much in the way of stereochemistry. But what else can we ask? You could put this on a separate note card, but since I have space, draw the product and what? The mechanism. And that's it. No clues. No, don't say that this is in unit 4. Don't say this is organometallic plus carbon dioxide, because that's not what I'm going to do on the exam. On the exam, this looks like an exam problem. Now, for your answer, yeah, you could put that this is reaction F, or that this is a great way to make a carboxylic acid. All those notes will be useful for you when you turn over your note card. So the idea is you have the front of the note card, make it look like a problem, okay? I know some students like to look through the practice problems and say, well, I had trouble with this particular problem. Let me put that on a note card just in case Dr. Gabriel puts it on the exam, okay? So the idea is you see this note card, okay? No other extraneous information. And then on a separate sheet of paper, you go ahead and work out the problem, okay? When you're done working out the problem, you flip the note card, okay? I don't like to bleed through, so I'll put it on a different note card and I'll just tape them together. On a separate note card, you do your answer. You give your answer. Okay? So they ask for the product, and the product is this. Oh, so what is the product? You have your organometallic. That's the dot. The dot is that carbon dioxide. We'll see in the mechanism how this happens, but there's your product. And what's the mechanism? The mechanism is this. Okay, so actually, let me give you a minute, maybe half a minute, to go ahead and complete the whole mechanism. After this first step, then you'd be ready for the proton, the acidic water. So it's really only 2 steps. Go ahead and work on that in your notes, and I'll be right back. We use a different colored pen, and you're allowed to use different colored pens, obviously on your notes, but also on the exam, just as long as you don't use red. Red is reserved for me. Okay. So that carbon that we just attacked, there's at least, well, there's one carbon-oxygen double bond. We have one oxygen anion. If you do want to balance, it's really not necessary. But if you want to conserve charge, right, net neutral on the left, net neutral on the right, and then H3O plus over the arrow or next to the arrow. And we have this. We have that. Li is not important. It's just a counterion, but we did create water also. Okay. Like I said, on the front of note card, no hints. But what would be nice on the back of the note card? Let's say you do this problem on a separate sheet of paper. You flip over the card and you see your answer. Do your corrections in red. But also, what if you're not getting this? It would be great if you could put a little note here. So this is on the back of the note card. This is reaction F. But what unit? So maybe a new notation. I should have done this from the very beginning. This is unit 4, reaction F. So this is not a cheat, right? It's not, you don't know this when you're doing the problem, but now if you're getting mistakes, you just look through your notes, look through the videos, find everything that relates to reaction F in unit 4, and then study those notes. Okay, so that's good. What's another good thing? I don't know. You could give yourself a reminder that this is dry ice. I think that's it. You could give yourself a reminder that you could literally do the substitution that on an sp2 carbon. So sp2 is okay. That's very rare. We actually never saw that before, or we could substitute. It's technically what? It's technically a substitution, right? We substituted carbon dioxide for this lithium. In organic chemistry 1, we said don't substitute at an sp2 carbon, only at sp3 carbons. So we could put a little note there that it's okay. I don't know. The last thing is we could say excess goes up in the air. And we have that. So that is my strategy when I do flashcards. Okay. Um, you could have a flashcard for synthesis. You could have a flashcard for mechanism. You could have a flashcard for um, uh, properties. Okay, conceptual things. But this one was a very standard. Oh, how about this? And this will be actually part of your extra credit. So let me make sure that I have this set off. Okay, back to uh, the notebook. Let's say this is for extra credit. Do 10 p.m. I do want to give you some stuff to do while I get the videos up and reward you with some extra credit points. I don't know yet. Total will be 4, but for this problem, I want to know. Some people were having trouble with the synthesis where I actually give you all the boxes. Some of you actually skipped it. So here's the synthesis. Alkane, first box. While there's no cumulative final exam, there's no way that you could get through Organic Chemistry 2 without knowing Organic Chemistry 1, or some of Organic Chemistry 1. But I'm asking for this first step, or first reaction in the synthesis. I want to get a bromine right here. Okay, does that make sense? Okay. Next thing is NaOET. So far, all of these reactions are Organic Chemistry 1. Bigger box because I'm expecting a product here. Okay. What am I doing again? The synthesis is this. This is gonna look a little strange, but I ultimately want to make this molecule here. Pretty cool. Alkane, probably from petroleum oil, has a lot of small alkane components, whether they're linear or branched. You have all of them. So you take petroleum, you refine it, you distill it, very cheap, and then you convert it into a carboxylic acid. Kind of at a weird position, right? Because my bromine is here, the more substituted carbon. So that's our task, our challenge to try to get the functional group on this carbon here. So I'm giving you some clues, right? Normally, under non-pandemic conditions, I would just give you this. Okay. So let me visualize what I have here. We have that. So here's a twist, HBr with peroxides, and I'll use H3OOCH3, a new product. A new product. Okay. How about this? Now I feel like some people, when they saw this problem, they got pretty frustrated and they couldn't get the first reactant. And actually, in all those boxes, I think there were 5 of them. The first one was difficult. But the thing is, that shouldn't sink you for the rest of the boxes, because even if you don't know this box, just cover it up. You should be able to know that product right there. Okay? You could work backwards. You could use other parts of the synthesis for clues. So here's another clue. I know we have several boxes sort of bunched together, and you may think that, oh, if I don't know one, it's just going to ruin it for everything. I won't know how to do any of the other boxes. But take a look at this product here. Um, how do you make this? This is a Grignard reagent. So you should know what goes in this box. Okay? And we're assuming that, yeah, probably the only thing that happened in this last reaction was to make the Grignard reagent. Nothing else is happening on other parts of the molecule. So even if you don't know box A, box B, maybe not even box C, you know the reagent for Grignard, right? It's Mg. And how do you make a Grignard reagent? You take the alkyl halide plus Mg. So now you know this is an alkyl halide, right? The thing is, well, we had an alkyl halide up here. Why do I make another one? Because I'm trying to shift it to this other carbon. Okay, you could get partial credit. You know, there were 5 boxes on that synthesis, the box synthesis, and each were worth 2 points. So even if you didn't understand the first part, I feel like there were enough clues to fill in the other boxes going backwards. And this turned out pretty well in terms of fitting everything in this sort of circle. But I think you could have some reagents to get the carboxylic acid. There's have to be 5 boxes again. 1, 2, 3, 4, 5. Okay. Let's go back to Moodle. I'll come back to this if you still need to copy this. But let me go back to Moodle to see when Jose's office hours and my office hours are. Okay, hopefully you can see my Moodle. If not, just speak up. Jose has office hours at 4:30 today, and mine are actually an hour before his. So um, you have 2 hours with us in the afternoon. Jose may be taking appointments either for today or maybe Thursday, Friday. I'm basically stuck to my table here for the next 11 hours. So if you want to see me some other time besides 3:30, just send me an email, and probably we can make time 15 to 30 minutes. Okay. And yeah, I don't mind. I don't mind if Jose helps you with. I don't mind if Jose helps you with the extra credit. And this is pretty significant, and it's something that I would like you to know. So let me make this plus 3% on exam 2. Okay, fill in the boxes. There is a link. There's more extra credit coming up, so just hang in there. There is a link for that extra credit. That's on today. So that's today's section. I'm having trouble speaking. Exam 2, extra credit, 4 points, maybe bumped up to 5, just depends. Due today, 7 p.m. tonight. Okay. Let me see what it looks like when I click it. Oh, nothing much. Okay. No one has submitted anything yet. So let me give you more opportunities for extra credit, and I'll see if I have time to introduce unit 5. Okay. Sorry about that. So there's plus 3 extra credit. There is one problem that maybe you can predict, or you have a feeling that I like this type of problem. And I do. I like a lot of problems. So here's a note card. Uh, and this will be another extra credit. So just, no, this will not be an extra credit. But pay attention because this could be on the exam. Okay. If I have this molecule, again, I am trying to make this look like an exam problem. And I think you know what type of problem this is. Or I think some of you can predict what I'm going to ask. I'm going to ask, make this alcohol 3 ways. 3 ways using a strategy of ketone plus organolithium. And how would I abbreviate organolithium? RLI. And that's it. Okay. Front of your note card in black for me. So anything that's in black is something that I would see literally on a textbook problem or an exam problem. I put my answers in blue. So here's the problem. The answer in blue is going to be this, or can be this. Okay. So after I'm done with the second note card, I'm going to paste it behind this front of the note card. But I'm going to recopy this, and I'm not going to do this whole problem. You can do this the rest of it at home. And let me show you at least the strategy, the way that I would work it out to get one of the ways with a ketone plus organolithium. This is the easier way. The harder way is to try to make something with an epoxide. Because again, for an epoxide, you're not attacking this carbon that's connected to the hydroxyl group. But let me work on this bond right here. Actually, let me list all of them. A, B, C. Let me work on bond C. Good that I have these note cards. So because for bond C, your ketone should look like this. Let's make sure, sorry, that it's a ketone, right? So you got to force yourself to make this an oxygen double bond dot. Why did I cover up the right-hand side? Because that's the bond I'm making. Imagine that you have an eraser. Erase that bond right there. When you erase this bond, you have 2 pieces. You have the piece on the left and the piece on the right. Right there. 3 carbon piece. To make bond C, my strategy would be this. It doesn't matter if you draw the ketone or the lithium first. And I am going to make the bond angles a little bit screwy, so you could see where the attack is. The attack is coming in from the right. You know that if you attack this carbonyl group with a nucleophile, this becomes an OH. Don't forget that you do have to have a protonation. So you are going to have 1 and 2. Now, this is interesting. My MGBR is I'm going to try to put it on the left because I'm attaching this carbon to the dot. So how would I do this? It's MGBR. The carbon has to be attached to the metal, but the BR stays for the organolithium. That makes things a little bit easier. If you're like me, I would never be able to study off of this note card. It's just too distracting. So, I'll plan it out and then I'll recopy it. a little bit neater. 2 H3O plus. I'm not going to draw the product because the product is this. Now, did someone say that in chat? Let me see what chat looks like. No, nothing important in the chat. So, but I'm missing a carbon. See, the piece on the right is 3 carbons. So I think that's good. I have space because this is one of the giant note cards. Put the strategy for A and B. Okay, so you'll do that. But the last problem that I want on that extra credit is going to be a doozy. It's going to be harder. Let me show you. If you saw the videos and you took notes and you studied your notes, I don't want to underestimate you. It's probably not that hard. But if you haven't done this before, haven't gone through this process, then this might be hard. And the question is this. Okay, again, let's set this off. Extra credit. 10 p.m. Wednesday. You already have 3 extra credit points available. Since this one's a little bit harder than what I had planned, we'll make it +2. So ultimately, by 10 p.m. Tonight, by 10 p.m. tonight, you could have already 5 points on your exam. And again, that's half a letter grade. This is going to be the easiest half letter grade for the exam. Okay. The problem is this. And I really like this problem. 1, 2, 3. Now, before I do anything, I just want to make sure that this is going to work. Oh yeah. No. Yes. I think this is going to work. Same A, B, and C. A, B, C. Now here's the problem. I know you can make this alcohol 3 ways. Using, we'll just go with Grignard. Grignard plus ketone. But here, I want one way to make this. Can you predict what I'm gonna say? Grignard plus, double checking because it is hard to visualize without drawing anything. Grignard plus, I can do it. Yes, Grignard plus epoxide. Why is that hard? Again, for Grignard plus epoxide, you're not making the bond between a carbon and a dot. You're making the bond between a carbon and the carbon next to the dot. Can you actually visualize? We're going back to the roadmap. This is in pink. When I do the retrosynthetic analysis, this arrow means comes from. How does my epoxide look like? It's gonna be this epoxide, but look how I'm gonna draw it. I'm going to draw it like this. Why would I draw it like this? Plus your Grignard reagent, which we already saw in the middle. You see why I'm drawing it like this? Because I'm visualizing this O in between these two carbons. So I'm drawing the carbon skeleton in the same pattern, a V. Like I'm not drawing it like this. If you're forced to make an alcohol via an epoxide, you have to ask yourself, is my O going to make a triangle here to the left? Or is my O going to make a triangle? Should I use an O that makes a triangle to the right? The thing is, with Grignard reagents, you're attacking the less substituted carbon. So it would be very hard if your epoxide looked like this, where the O is connected to this dot here. You could do it, but you would need a different Grignard reagent, right? You would need a Grignard reagent that has this carbon attached to it. Actually, it's not going to work either. I can't even tell if that is even possible. No, it's not. Right? Because if your epoxide was here between these two carbons, to get an alcohol that looks like this, you would have to attack this carbon on the end, and there's nothing at the end. You didn't attach anything at the end. So that's the challenge. Because for this molecule, there is actually only one way to do this via an epoxide. Only one way. So what are you doing? You're redrawing your target. I'm redrawing it because this analysis with the pink lettering is if I was going to attack a ketone, attack the carbonyl carbon, the dot. But here, what carbon would I be attacking to make this alcohol? It's the dot next to the alpha carbon. So either I make the epoxide here. Oh, that doesn't look good because this carbon is too full already. Like if I make a triangle here, that carbon has 5 bonds. See, that already eliminates this carbon here. I could make the epoxide here, right? But that doesn't make any sense because I'm not attacking this carbon here, right? This would be the less substituted. So if I had more junk here, yeah, I could have used an epoxide that looks like this. That only leaves us one opportunity. So here's your hint. Your epoxide is between these two carbons. These two carbons. Okay. Again, I'm visualizing that epoxide because the piece that's being added, the piece that's attacking that epoxide, has to attack the less substituted carbon. Has to attack the less substituted carbon. Has to attack the less substituted carbon. I know I've beaten that horse to death. So I'll post these notes. It'll take me a while to scan them, but on one page of your Zoom notes, or at least my Zoom notes, those are your extra credit. So it'll be for 5 points. I'll change Moodle. So it says that by 10 p.m. today, if you get these problems on one PDF, okay, and they're correct, you'll get 5 points on the next exam. All right, so hopefully that's helpful. What I really wanted to be helpful is how to design a flashcard. And also for that extra credit, I think most people got the 2 points. If it's exceptional, okay? I'm not going to call them out, but someone handed in 43 pages of stuff. Okay, I looked through it. They were flashcards, but still, 43 flashcards in a week. Hopefully it helped them on the exam, but it shows that you're reorganizing your thoughts. Some people were very good at making roadmaps, and some people were. I saw a strategy where they took the existing notes and then in a different color, like highlighted, like really important concepts or really important things that would trip people up on an exam, like warning signs, like flags, basically, or stars. And that's perfectly fine. That's another technique. Um, one person gave the reading notes, and I'm hoping it's worth their time to read and take the notes. I think they did well on the exam. But there are many ways to on your own come up with some study aids, flashcards, cheat sheets, recopy notes, whatever. Okay. Um, all right. For the last, I know we've been going for an hour, but for the last maybe 10 minutes, actually, before we do that, are there any questions? Let me check the chat and let me check your hands. Any questions? All right. So Jose, let me try to read his question. I'll read it out loud. Can you not also have a secondary organometallic so there are even more possibilities when making your electrophile an aldehyde? Uh, class, I'm not understanding what Jose is saying. I will talk to him. I have no idea what he's saying. Let me see. I'll talk to him later. If there's no legitimate good questions from the class, let me introduce carboxylic acids. Let me show you what's available first. Let's go to Moodle. And let's go to the YouTube. Again, for Unit 5, we are skipping all the lipid stuff. I don't think I put any lipid reading, so that's good. All the reading that I assigned in the suggested reading, textbook reading, those are all good for your exam. So, Unit 5, carboxylic acids. I didn't get a chance to say, I'll probably say it in the second video. So I am going to put more Unit 5 videos. If I if if I get a burst of energy and I can put the Unit 6 videos, that will be what's due on Friday. But for Unit 5, it's carboxylic acids. There aren't a lot of reactions. I would say there are maybe 5 maximum. But I didn't get a chance to talk about the illustration. I want to talk a little bit about it. So this is, as you could probably tell, art. My art skills aren't that great. The marijuana plant, and this is THC. Actually, the active ingredient is a precursor, and it. By the way, I'm not an expert, so if you know more than I do, um, uh, don't interrupt me. So, oops, let me go back. Okay, hopefully everyone can see the YouTube screen. The precursor is a carboxylic acid, and it's right here. And the thing is, I guess you could activate uh, marijuana or THC. This is actually THCA for the acid part. And you bake it or you set it on fire. Or I don't know how to do it, but you remove this group right here to get a new molecule. So this is ah Sorry, I'm not sure why that keeps happening. Let me make sure my screen is shared again. Okay. Jose, if they're not seeing what I'm seeing, let me know. So, we're back on the YouTube screen. What I want to say is that you remove carbon dioxide. So for the organometallics, we showed a way to add carbon dioxide to make the carboxylic acid. It's not the same mechanism. It's not the reverse, but it is a way to remove carbon dioxide, and this is called decarboxylation. And if you look online, you could call it decarb. It's not removing carbohydrates. Decarb in this case is removing carbon dioxide, and this is actually THC, I guess you could say the active form of THCA. Okay? The decarboxylation reaction and the mechanism will be talked about in the last video, so probably video number 3 or 4 of Unit 5, but I just wanted to um, introduce that because I didn't get a chance to do that on the first video. So if we go back, oh shit, same shirt. If we go back, expect 3 or 4 more videos, and then the notes will be based on Unit 6, which will be right under here. Unit 6 will be carboxylic acid derivatives, meaning that we're going to take carboxylic acids and make different molecules, but it's really considered a derivative because when you hydrolyze these new molecules in Unit 6, you go back to the carboxylic acid. I feel that I didn't expect anyone to watch that Unit 5 video, which introduces carboxylic acids. So instead of putting in a lot of new material now, let me just end a little bit early. Oh, don't leave yet. I'm not going to talk about Unit 5 right now. Go ahead and just watch the 3 or 4 videos that will be posted later today. Work on your extra credit. Don't worry about the lab. Try to meet Jose or me to get those 5 points out of the way, right? You get 5 points every week for attending an SI session. Start collecting your questions. Um, start doing the practice problems. All of that. Oh, this is what I wanted to do. The final thing I wanted to do is look at the exam one. And then we can quit early. Back to Moodle. I said that the exam one answers are posted here on Monday. Exam one answers. There are a couple of things I wanted to, I think, point out. Adjust your screen and move your chat or video off to the side so you can see the whole page. This one's pretty straightforward. I had no really issues with that. Oh, if you do have a question, I can see your hands in the participant list if you want to raise your hand or ask Jose to ask a question, or you can just speak up. So anyway, that's page 1. Page 2, there's no acid in the first reaction, so you attack the less substituted. And you know that we consider this an SN2, so the backside attack. With excess alcohol, I expected you to go all the way to the acetal. Some of you stopped at the hemiacetal, and I gave partial credit, but a lot of you actually had the wrong number of carbons. There are 5 carbons here. 1, 2, 3, 4, 5. Yeah, the 5th carbon. So there should be 5 carbons like to the left of the molecule. I think some of you were short. This is tolerance reagent. You just convert the aldehyde into carboxylic acid. To make this a 6-membered ring, you don't use this oxygen because the 6 atoms are this 1, 2, 3, 4, 5, and the oxygen is part of the ring. So this is atom number 6. So you can make a hemiacetal, you can, by using oxygen, which is, I consider this atom 6, attacking atom 1. The naming, I wasn't sure if I was wrong because a lot of people had a different answer, but you gotta alphabetize E first M. I was a little bit surprised about this. It's maybe the format of the problem freaked people out, but this is the Vidiq reagent. This is how to make the Vidiq reagent. Remember, you take an alkyl halide and you add pH3, but the Vidiq reagent is an ylide, a negative and a plus next to each other. So if you recognize that this was phosphorus, and the only time we work with phosphorus with the Vidiq reaction, you know that the Vidiq reagent is minus plus next to each other. So that will tell you that you remove this hydrogen here. The hydrogen here is actually more acidic because of resonance, right? This anion is stabilized by another resonance structure. This one also was sort of use what you know or apply what you know. I was very happy that many people added a second H to this carbon, the left substitute carbon. But it was a little bit weird that there was an OH here for a lot of you. The OH is only on the right carbon because this bond gets broken. It's basically a ring opening, right? And we get an OH on this carbon. Now the weird thing that I caught later was that nothing's chiral. It's when you add this hydrogen. So I could see why you thought it was chiral because maybe you had an OH here, but if you got this product, there should not have been any wedges and dashes. It's this molecule right here on the right. Okay, so that was a little bit subtle, and the rest is this one. I don't think I took off points if you mention resonance and you mentioned that the carbon is very electropositive. But I did say you may want to consider resonance, and this is the resonance, and that this carbocation is less positive because you have 2 groups donating electrons into it. This only has 1 alkyl group. So this carbon is more attractive to the nucleophile. The linkage, the formatting is alpha or beta, and then which 2 carbons you're connecting. This one was tricky because I myself, when I'm making the answer key, I protonated the OH. But later on I realized, well, no, I have to break a bond in the ring, so it's not this that I want to leave, it's this oxygen that I want to leave. So look what happens when you protonate it, then you have the ability to break this bond by making a double bond. The idea here is, though, this is a hemiacetal. So what you would do is you would look through your notes for the acetal mechanism, find the hemiacetal, and then work backwards from there. The other thing is that I did show the full mechanism of acetal hydrolysis. So chug along the acetal hydrolysis until you get to the hemiacetal, and then you start from there. These 3 steps are literally inside the 7-step mechanism of acetal hydrolysis. So if you find the hemiacetal, yes, you will see that the protonation will be on this oxygen, not the OH oxygen. So that was a little bit more, you can't, I think with enough time, or if people did not panic as much or under so much stress, I think eventually people would understand that this was in your notes. Okay, it's just hidden in a 7-step acetal hydrolysis. It's in the middle. Here, I tried to make the alkoxide the molecule on the left, but I realized that I'm trying to attack a secondary, oh sorry, an sp2 carbon. So that's not good. For Williamson ether, you have to attack a primary alkyl halide. Okay, and the last thing, and then I'll let you guys go. Don't look at the box. Don't look at the starting material. Look at this right here. You know that's the cyclic hemiacetal. Oh, get rid of that hemi. This is a cyclic acetal. So how do you know the starting material for cyclic acetal? You do hydrolysis. That's your dot. So when you do your cuts here and here, the dot has the carbonyl group originally, and it's right there. It was tricky because it almost looks like you're protecting the diol, but really you're protecting each other. The diol is protecting the carbonyl is protecting the diol, but all of you were familiar or are familiar with cyclic acetals as protecting groups. It's just that it looks a little bit trickier because the diol part is the one that looks more complicated. It's more complex. What about the idea that, okay, maybe I punted this. Maybe I have no idea what's going on here. Well, forget it. Skip that. Take a look at this reaction here, right? Maybe you aren't used to seeing the Jones reagent like this, okay? The oxidation. But also here, Lindlar. So you know that you had a triple bond in this box somewhere, okay? So that's maybe another clue that maybe if you don't know the second box, maybe you could get the third box and then work backwards from there. A lot of this, and then I'll let you guys go. A lot of organic chemistry is not. I do say that with more practice, it'll become automatic, but there'll be problems where even for people who've been doing this for 10, 15 years, you know, they're trying out different strategies. They're doing a lot of trial and error, right? Um, they're putting a lot of wrong answers and then eliminating those and adjusting those. So the main point is, you know, when you initially get stuck, there should be a pathway to get at least partial credit. Okay. Um, Here, the extra credit, there are multiple ways. I think actually the best way is this one at the bottom, 2 reactions. Okay. I accepted the one with 3 reactions because here you're using an epoxide, which I was actually initially trying to make you guys use. Okay. Are there any problems or comments or questions? Jose has office hours this afternoon, and so do I. I will, the first thing I'll do here is I'll post um, the notes so you have at least a PDF copy of that extra credit. But you can start working on it now on your on a separate sheet of paper. And I'll also, it's going to take a while to process because it's a super long video, but I'll process the video and put that also as a private YouTube link or a YouTube link on Moodle. Okay. If you scored in the 70s, you know your SI sessions and your notes check should bump that up. Maybe even to a, you know, from a C minus to a B minus. I don't know when the withdrawal date is, okay? But if you didn't do very well, or if you think it doesn't reflect how much work you've done, talk to Jose, talk to me. There should be ways to maintain the amount of studying, but make it supercharged, super efficient. So it's not a waste of time, or it's not a good use of time. Jose, you'll stay in the room, but for the rest of you, if there are no more questions, um, I think I'll see a lot of you on Friday, okay? Or hopefully during office hours. Mm, people are leaving. Ah, awesome. Who was not? Oh, let me stop the video before I say anything wrong. Yeah, why? But wait, see what?